This video covers important definitions and laws of thermodynamics, essential for success in exams like JEE and NEET chemistry. Thermodynamics is the branch of science that quantitatively explores the relationships between heat and other forms of energy. A system is the part of the universe selected for study, while the surroundings are everything outside it. The boundary is the real or imaginary surface separating them. Systems can be open, exchanging both matter and energy, closed, exchanging only energy, or isolated, with no exchange of matter or energy. The state of a system is defined by state variables like pressure, volume, temperature, and composition. Extensive properties, such as mass and volume, depend on the substance's amount. Intensive properties, like pressure and temperature, are independent of it. Internal energy, denoted by U, is the total energy of all molecules in a system. The change in internal energy, delta U, is the difference between final and initial states. The first law of thermodynamics states that energy cannot be created or destroyed, only transformed. This is expressed as delta U equals Q plus W, where Q is heat and W is work. Work, W, is energy transferred by force, causing an object to move. Heat, Q, is energy transferred due to a temperature difference. Enthalpy, H, is defined as U plus PV. The change in enthalpy, delta H, equals delta U plus P delta V. At constant pressure, delta H represents the heat absorbed or evolved. The second law of thermodynamics states that the entropy of an isolated system always increases during a spontaneous process. For a spontaneous process, the change in entropy of the universe is greater than zero. Entropy S measures disorder or randomness. A higher entropy indicates greater randomness. The change in entropy, delta S, is calculated as the reversible heat divided by temperature. The third law of thermodynamics states that a perfectly crystalline substance at absolute zero, 0 Kelvin, has an entropy of zero. Gibbs free energy G is defined as HTS. The change in Gibbs free energy, delta G, indicates spontaneity. Negative for spontaneous, positive for non-spontaneous, and zero for equilibrium. The relationship between standard Gibbs free energy change, delta G degree, and the equilibrium constant K is given by delta G degree equals RT ln K. Hess's law states that the total enthalpy change for a reaction remains constant, regardless of whether it occurs in one step or multiple steps.